In this video, we're going to find the formula for the area of a circle. Even though a circle looks quite different than the shapes we have been talking about, we can use the move and reattach strategy to derive the formula for finding the area contained within the circle. Okay, so we can't turn this into a rectangle or a parallelogram, at least not easily. So here's what we're going to do. Notice figure A is a circle and it's cut into 8 pieces. So I cut it into 8 equal pieces, and so I made the top pieces green, the bottom pieces are blue. In figure B, so you could think of this as a pizza, I rearranged these pieces. So there's alternating greens and blues, and notice how they fit together. We want to approximate the lengths of the 2 line segments labeled with question marks in figure B in relation to the radius and the circumference of figure A. Okay, so notice this side right here is the side length of one of these. You want to think of them as slices of pizza, so it's equivalent to this. And that is equal to the radius of our circle, since it's the distance from the center to the outside of our circle. So this question mark is the radius. Okay. Now let's look at this segment. So we're actually not going to look exactly at this segment because we're going to look at, find a good highlighter, how about this pink one? We want to find this length. So notice it's a little bit arced because we have a circle. So we want to find the length of these 4 arcs. Well, notice those are the green circles, or the green slices, and it corresponds to this length right here. Well, the circumference of the circle is the total distance around the circle, and this is half of that circumference. So the circumference equals, we'll write it as 2 pi times the radius, and we have 1/2 of the circumference, so that's 1/2 of 2 pi times the radius, and notice the 2's cancel out. So 1/2 the circumference is pi times the radius. So we could say that this length right here is either half the circumference, or in terms of the radius, it's pi times the radius. Okay. So let's look at the next slide. Now this wasn't a perfect parallelogram or a perfect rectangle because the bottom and the top were actually arcs. Okay. So we need to imagine you're cutting this pizza into more and more slices. So here it is when I cut all of these in half and rearrange them. Okay. Then I cut all of these pieces in half and rearrange them. And if you imagine we continue to cut the circle in figure A into more pieces, we would get the diagrams below. From left to right, the circle is cut into an increasing number of pieces until eventually it just looks like a rectangle. So describe the change in shape of the resulting figures as they are cut into more pieces. So the shape looks more like a rectangle when we cut it into more and more pieces. So the more pieces we cut it into, the more it looks like a rectangle. If the last figure is equivalent to the area of the original circle after cutting the circle into really small pieces, what is the area of the circle in terms of its radius and circumference? So remember we said in the last slide that this length would be the radius and this length would be 1/2 the circumference. So in terms of the radius and the circumference, the area is 1/2 times the circumference times the radius. Well, now we want to write this, since we can write the circle, or sorry, the circumference is 2 pi r. We're going to write a general formula for the area in terms of just pi and the radius. So we're going to replace the circumference with 2 pi r. And we said before that this simplifies to, we could think of the 2's as canceling, and this length is pi times the radius. Okay. So if we look at this rectangle and we want to find its area, the area in terms of just the radius is pi times the radius, or pi, radius times radius, we can write as radius squared. And this is our formula for the area of a circle. The area is pi times the radius squared.